Lesson 2, Types of Data. It is important to know the type of data you are dealing with in order to know what type of statistical analysis technique to apply. Specific statistical analysis techniques only work with particular types of data. For instance, with non-numerical data, such as students' political party affiliation, calculating the percentage of students who are either Democrat or Republican is an appropriate statistic to analyze. For instance, with numerical data, such as the age of students, calculating the average age of students is a reasonable statistic to analyze. Data can be classified into two basic types, qualitative or quantitative. Qualitative data is categorical in nature. In essence, qualitative data represents information regarding a quality or attribute, not a quantity. Quantitative data is numerical in nature. In essence, quantitative data represents information regarding a quantity or amount, not a quality. For instance, the political party affiliation of students, the colors of M&Ms in a bag of milk chocolate plain M&Ms, the zip code that a household resides in would all be classified as qualitative data. The political party affiliation, Democrat, Republican, Independent, Other, are categorical. Colors of M&Ms, red, yellow, green, blue, orange, brown, categorical. Zip code, a little tricky. There are numbers like 95677, but sometimes numbers are used just as names. And with zip codes, that's the case. The U.S. Postal Service has just designated a certain region to deliver mail to as a zip code, a number. That number is not actually relevant to that specific area. It's just a convenient way of labeling or naming that zip code. For instance, the age of Sierra College elementary statistics students, the number of M&Ms in a bag of milk chocolate plain M&Ms, and the total annual household income in dollars would all be classified as quantitative data. Because each of these values, age, number of M&Ms in a bag, and total annual household income, are all quantitative, numerical in nature. Quantitative data can be further classified as either discrete or continuous. Discrete data can take on only separate values with no intermediate values. In general, discrete data denote counts, that is, how many, and are usually represented by whole numbers only, such as 0, 1, 2, and 3. Continuous data can take on any value over a certain interval. In general, continuous data denote measurements, that is, how much, and are represented by any real number, which includes whole numbers such as 0 and 1, but they also include fractions and decimals, such as 2.5, 3.14. For instance, the number of units a student is enrolled in this semester, the number of M&Ms in a bag of milk chocolate plain M&Ms, and the total number of TVs in a household would all be classified as discrete data. So discrete data typically represent counts, such as the number of M&Ms in the bag or the number of TVs in a household. But with regards to number of units students are enrolled in, even though some courses are worth half a unit, discrete data only gives values at distinct separate results with absolutely no intermediate values. So even though there is a half unit class, and then there are 1 unit, 2 unit, 3 unit, 5 unit classes, it's still considered discrete because there are no unit classes offered by any intermediate values. That is, no courses given anywhere between the 4 and 5 units, or between a half unit and 1 unit. For instance, the age of Sierra College elementary statistics students, the weight in ounces of a bag of milk chocolate plain M&Ms, and the total annual household income in dollars would all be classified as continuous data. So continuous data would provide results that could take on any value on a certain scale. So age is a measurement of time in years, can take on any value on a continuous scale. Weight, measured in ounces, can take on any value on that continuous scale. And household income in dollars can take on any value on a certain interval. So, to summarize, when we try to categorize data by the different types, in general there are two types of data. Data is either qualitative, which is categorical in nature. That is, it basically uses words and not numbers to gather the information. Or data can be quantitative. Quantitative data is numerical in nature. That is, the information is collected as a number or quantity. Quantitative data can be further classified as either being discrete. Discrete is the numerical values take on separate values with absolutely no in-between or intermediate values. Or continuous. Continuous data can take on any value on a given interval. So now let's try some examples of classifying data by type.